All right, let's talk about a new protocol that is kind of quietly getting ready to completely change how we build real-time apps on the web. It's called WebTransport, and trust me, it's a huge step forward.
But before we dive into the deep end, let's just ask a really basic question. For everything from multiplayer games to live streams to just simple chat apps, the web absolutely needs fast two-way communication. And yeah, we have tools for this. But are they really good enough for what's coming next? Let's find out.
See, to really get why WebTransport is such a big deal, you first have to understand the problem it was built to solve. And for that, we're going to need to take a quick little trip back in time. So way back when, the web was built on a super simple model. You ask for a page, the server sends it. That's it. To get real-time stuff working, we came up with these clever, but let's be honest, kind of clunky workarounds like long polling. Then in 2011, WebSockets showed up and it was a total game changer. Finally, true two-way communication over a single connection. And later, HTTP/2 gave us streams, which let us fire off a bunch of requests at once without them tripping over each other. But even with all that progress, there was still a fundamental problem lurking underneath. Yeah, WebSockets have some hidden costs. They're built on a protocol called TCP, and that means they suffer from something called head-of-line blocking. Now, what does that mean? Well, imagine a single tiny piece of data, one packet, gets lost on its way to you. With TCP, the entire connection grinds to a halt, waiting for that one lost packet to be resent. Everything just stops. Plus, WebSockets have some old baggage, like a security thing called masking that isn't really necessary anymore. But the biggest thing it's missing, there's just no way to send data unreliably, to just fire and forget, without worrying if every single bit gets there perfectly. So, with all those challenges on the table, the stage is set for a new contender, and that's where WebTransport steps into the ring. It's a modern protocol designed from the ground up to fix these exact problems. So what is this thing really? Well, WebTransport is a brand new web API that lets a browser and a server talk to each other in both directions. But here's the kicker. It's built on top of the absolute latest web protocol, HTTP/3. And this is its secret sauce. HTTP/3 doesn't use TCP. Instead, it uses a newer protocol called QUIC, which runs over something called UDP. Now, this completely changes the game. By using QUIC, WebTransport totally avoids that head-of-line blocking problem we just talked about. A lost packet in one stream doesn't hold up any of the others. It's a massive win. But that's not all. WebTransport actually comes with two totally different ways to send data, which gives developers an incredible amount of flexibility. I like to think of them as its two superpowers. And the easiest way to get it is with an analogy. First, you've got reliable streams. Think of this like sending a package with a tracking number. You know for sure it's going to get there, and it'll arrive in one piece. Then you have unreliable datagrams. This is more like sending a postcard. It's super fast, super cheap to send, but hey, there's no guarantee it'll arrive or in what order. Let's dig into that first superpower, the Streams API. This gives you that guaranteed in-order data delivery. It's absolutely perfect for things that have to get through, like chat messages or, a critical event in a game. And the best part is, thanks to QUIC, you can have a whole bunch of these streams running at the same time, and they won't get in each other's way. And now for the second superpower, the Datagrams API. This is what's really truly new for the web platform. It's a best effort delivery system, just like UDP. It is designed for data where having the absolute latest information is way more important than having every single piece of old information. Think about live video frames or the constant position updates of other players in an online game. A few dropped packets here and there are fine as long as the new data keeps flowing fast. So what does all this new power actually unlock? Well, it means sending game updates with the lowest possible latency. It means watching media streams with way less jitter because you're not stuck waiting for lost packets. It means a server can blast out high-frequency notifications. But really, what it means is that for the first time, developers get to choose the perfect tool for the exact kind of data they're sending. That's a level of control we've just never had before. Okay, so with all this new power, you're probably wondering, how does WebTransport stack up against the stuff we already use? Let's put it head-to-head with the current champs of real-time web tech. And the first, most obvious question every developer asks is, wait, so does this just replace WebSockets? And the answer is, well, it's a little more complicated than a simple yes or no. Okay, look, where WebSockets gives you just one single reliable pipe, WebTransport gives you multiple independent streams, plus those unreliable datagrams. It completely gets rid of head-of-line blocking, and it connects faster. But, and this is a big but, WebSockets has been around for over a decade. Its ecosystem of libraries and tools is massive and mature. So no, WebTransport isn't a simple replacement. It's more like a powerful evolution for those use cases that demand peak performance and control.
All right, what about the other big name in real time, WebRTC? Is WebTransport coming for its job too? Not really. They're actually designed for totally different jobs. WebRTC is all about peer-to-peer, connecting two browsers directly for things like a video call, with no server in the middle. WebTransport is strictly client-to-server. A really key thing to understand is that setting up a WebTransport server is way, way simpler. You just need an HTTP/3 server. WebRTC, on the other hand, involves this incredibly complex dance of multiple protocols to get two peers talking. They just solve different problems. So it's clear WebTransport is powerful, it's flexible, and it fills a real need. So where does it stand today, and where is it all headed? Before we get to the roadmap, I just love this quote from one of the official meetings where they were designing the standard. It's this funny, self-aware reminder that even when you're building world-changing technology, a lot of the hard work is just passionate engineers arguing over the smallest details, like what to name things. It really shows you the human effort that goes into building the web. And all that hard work is really paying off. WebTransport is here. It's already supported in Chrome and Firefox, and you can turn it on in Safari with a feature flag. I mean, having 3 major browsers with implementations, that means the foundation is officially laid. It's becoming a reality. And the momentum right now is just undeniable. The official spec is nearly done, and the browsers are constantly improving the versions. But what's really, really exciting is that people are already designing new protocols, like Media over Quick, that are built to run on top of WebTransport. So it's not just a cool new feature, it's actually becoming a fundamental building block for the next generation of the web. And that leads us to the final, and honestly, the most exciting question of all. With this new ability to send multiple streams of both reliable and unreliable data at incredibly low latency, what are developers going to build? What new apps, new games, new collaborative experiences that we can't even imagine today are going to be possible? WebTransport gives us the tools, and I, for one, cannot wait to see what happens next.